Hello everybody, I am Mahita and today I'm going to explain you guys about page sharing and page replacement. So coming to page sharing is a technique where various processes, programs or virtual machines share a chunk of same memory or common memory instead of having each copy of the same memory. So let's see an analogy here. The people of CSC, students of CSC are preparing for the same examination from the same study material. Instead of each student having their own set of notes, they decide to share only one set of notes. Similarly, as we see in this presentation here, we have three processes P1, P2 and P3. Here, each of the processes consists of their respective page tables. That is P1, a page table for P1, page table for P2, and page table for P3. We can see, as we observe, we can see that each process have three common pages, that is ED1, ED2, and ED3. And when we see in their respective page tables, we can see that all of the three pages are pointing to the same frame number, 3, 4, and 6. Here, if we see in the frame table or the physical memory, we can see that ED1, ED2, and ED3 are occupying the third, fourth, and the sixth frame numbers. So we can say that all of the three processes are sharing only one copy which is present in the main memory. So we can conclude that this is page sharing. Now let's discuss the topic of page replacement. Generally, we see that we bring the pages from the secondary memory to the main memory, right? But when the main memory is full and there is a page to be added into the main memory, there is a problem. Here is a place where we use page replacement, where the operating system decides as to which page from the main memory, which is currently in the main memory, is to be evicted so as to make room for the new page that is to be added. This is called page replacement. As we can see, the page that is decided to be evicted is called as the victim page. As we can see here in the presentation below, basic page replacement involves the location of the desired page on the disk. And if the frame found is free, then we can use it. Or else we use page replacement algorithms to select the victim frame. After reading After reading the desired page into the free frame, we update the page and the frame tables. This is called the basic page replacement technique. As we can see in this presentation here, we have the physical memory and the page table consisting of the victim's frame number and the new page's frame number. So it involves four steps basically. The first step consists of swapping out the victim page. After the operating system selects the victim from the physical memory or the current memory, it swaps the victim page. After that, the second step is where we update the page table in which the frame number of the victim is changed to invalid. In the third step now, we see we swap the desired page into in place of victim. And the fourth step again involves resetting of the page table for the new page. This is the basic page replacement technique. Before getting to know about the page replacement algorithms, we first need to know about page faults. So page fault is a phenomenon which occurs when the desired page is not present in the main memory. The process is said to be more feasible when the page fault rate is the lowest. As we can see here in the graph, which is across the number of frames and number of page faults, we see that as the number of frames increases, the number of page faults decreases. And thus the feasibility of the process increases. Now, coming to the various page replacement algorithms, the first one comes the FIFO algorithm, which is the first in and first out algorithm. So the FIFO algorithm is nothing but it works by simply replacing the oldest page with the earliest page. That is, with the page that is there in the memory for the longest period of time with the one which has just entered into the memory. So simply, the FIFO algorithm replaces the oldest page whenever a page fault occurs. In the presentation, we can see the Belides anomaly. This is a drawback in the FIFO algorithm where this is a phenomena where if the number of pages increases, the number of page faults are also increasing. So coming to the optimal algorithm, we replace the page that will not be used for the longest period of time in the near future. In other words, it predicts the page that will be accessed in the further future and replaces the page when page fault occurs. So we can say, although it provides the lowest amount of page faults, it is not practically possible because it requires the knowledge of the future memory accesses, which is not practically possible. Now, coming to the least recently used algorithm. In least recently used algorithm, we replace the least recently used page with a new page that needs to be brought into the memory. It works on the principle that the least recently used pages will not be used in any near future. In this algorithm, LRU requires to maintain the record of all the page accesses so as to determine uh, which page is least recently used. So it becomes quite difficult for the user to keep on updating the access history. So that's it, guys. Thank you for participating with me in this session.